So since I've owned this new CNC mill, it's a Cancam Z540. I haven't really been able to get the automatic probing routines. I've never really been able to get them to work well. So I've taken on the task of basically making my own set, and it's gone well. Really, some things better than others. And I was working on the fourth axis probing. It was a sort of I ripped off David Loom's fourth axis tramming program, um, and there was a glitch. And I'm not a coding expert or a computer expert by any means, but I've been having a lot of luck with this Claude AI system. What I've done is sort of I've started a project, and in the project instructions, I sort of laid out the set of rules that it created in a prior prompt. And I copied and pasted all my macros from the machine so that it could understand how they work. And it's largely based on a FANUC system, but one of the rules I made was after a macro is created, we'll update this sort of global project here with a direction, what we change, sort of a change log, and then um, yeah, I'll paste it into the next chat. And every time we update a program, we end it off and we started in a new chat just to keep a fresh context window. Um, at least that's how I think it works. But anyway, I was trying to run this fourth axis job and I smashed my probe. So this was program number 17, and I'm trying to integrate it into Fusion 360. So I smashed the probe. It's a Friday afternoon in Northern Alberta, and there's like zero chance of me getting one until the middle of next week. So I'm trying to make the most of the weekend, and I think I've come up with a pretty interesting solution. So I was able to salvage this sort of ceramic tube somehow. The ruby that's supposed to be on the end is just absolutely destroyed and turned to fine powder. So what I did was I cut apart a ball bearing. Ouch, that's sharp. Yeah, cut apart a ball bearing. Took some of the bearings, the balls out of it. Um, I've sort of attempted to glue it on. That's definitely the most spherical thing that I have kicking around my shop right now. Um, However, I thought maybe I could use the laser, the fiber laser, to burn a hole in it, and I might get a bit more purchase. Because as it stands right now, I don't think if you could see that the ball bearing is just sitting on top there, and being sort of a highly polished surface, I have very little faith that that is going to actually adhere. And I must add, the purpose of me doing this is just sort of to get me by for the weekend so I can finish out my programs and be done with this project so that I can increase my productivity in the future. But for now, we're just trying to make it happen. I plan on drilling a hole. This is a piece of nickel plated 3/8 copper, um, just for work holding, let's say. I'm going to drill a hole maybe slightly larger than the diameter of the ball. So about 6 3/4 millimeters. I don't know what that converts to in fractional drills, but so I want to sort of stick it in there and then just stake the copper over it so that it doesn't rotate while I shoot the laser at it. Oh, yeah. I think that's going to work lovely. So this is purely just for work holding. I think it's going to be just fine for what we're trying to accomplish. I'm just trying to get it centered up as good as I can. Very hard to tell because of the reflective surface, but it's just got to be close. Any error we can just sort of tram out later. Wow, that's not doing shit. Let's try play with the focus as we... Nope. Maybe got to go the other way. There we go. Coming down. And we can start to hear it now. There you go. So I'm just bringing the focus down. This is, in my opinion, one of the best ways to set up your laser. Like, those 3 dots get you close, but going by sights and sounds is the best way to tell you when you're really dialed in. I can't really see how it's doing. I mean, it's making a cut. The copper is extremely warm to the touch. I guess it's doing a good job of sinking the heat out of it. I'm just going to put a bit of water on there just to maybe get some evaporation going. Huh. I wonder what will happen if I try to shoot the laser through the water. Damn. It doesn't care. I can really start to see that hole is probably, I don't know, a good 1/8 of an inch deep. At least. I'm actually blown away with that result. Sort of, wow, that might work all right. We'll try to get it out of here and see how it looks. Here you can see the walls obviously have some kind of taper, but really the most impressive part is sort of how perfect the surface finish is for gluing something. But wow. Of course, the glue on the polished one didn't hold up. But we'll see if this one fits. Oh, come on, look at that. Probably could have gone a bit deeper, but wow. I think that's going to work. Looks pretty good that way. For an MDI mode, tool 1, M06 input. Make sure our rapids are turned down. Feeds 100, should be all right. And cycle start. This machine has crazy fast rapids. It's unbelievably scary how fast the table can jog. But let's see how bad we are off the start. Keep in mind the ceramic shank also popped out, so I had to glue that in. I'm not really any good at doing this kind of dialing in. What is that? We're within 15 thousandths or something? That's honestly unbelievable. This is honestly probably something I should do more often. But, I don't know. With the way I program, kind of like to use sort of soft jaws for obtuse, so it's just more or less to get me in the ballpark. But maybe with these new macros that I'm building, that'll change. There we were within 5 thou. That's high. Right now, that's running out within less than 1 thou. Crazy. Absolutely crazy. Okay, that's actually unbelievable. I'm thoroughly impressed with that as well. So this is the program that killed my last probe stylus. So the idea is you want to be able to manually or automatically tram this in with the probe. So the plan is the probe will jog over to one side, touch, jog over to the other side, touch down, do some math, and then figure out the angle or difference, and then become perfectly parallel to the table, and then reset the work coordinate. So when I'm running a job or setting up, let's say, it should be quick rather than having to go back and forth with the dial indicator. Oh, let's try again. There we go. Come on down, baby. Touch again. Come on over. Touch down. Touch. Now it should come here and back up. Correct. All right. That looks like it worked. I can see my work coordinate is set to 0. Now, what we get the dial indicator and see how well we did. This should be really close to 0 if it worked. Wow. Okay. That's easy. All right, for the final act, we're going to probe this 1, 2, 3 block using this new macro that I built. And just to clarify, the original macro structure was inspired by Smith Coding and Design's macro library. He wrote his macros, obviously, to suit his machine. I believe it's a Syil X7 with a LNC controller. What I did was take that concept and adapt it to my GSK controller. I exported my OEM probing macros straight from the controller, fed them into Claude Code, and had it analyze how my machine actually handles probing logic, because the syntax and structure are a bit different. Once it understood my OEM routines, it rewrote the macro set so it would behave like Smith's workflow, but function properly on my controller. It even helped adjust the custom post processor so everything plays nicely together. And honestly, I'm impressed. Other than that one probe tip incident, it's been working extremely well. If you're into figuring this stuff out as we go, please make sure you subscribe. There's a lot more coming. Thank you.